So moving ahead to the 13th question. Okay, well, a body A starts from rest. Initially, what was the condition of the body? It was in rest condition. So initial velocity is 0. Acceleration was given as a1. Okay, after 2 seconds, another body B starts from rest with an acceleration of a2. So first body acceleration a1. After 2 seconds, the second body also started its journey, and with acceleration a2, two different acceleration if they travel equal distances in the 5th second. So they traveled equal distances in the 5th second. But remember children, the first body has traveled 2 seconds more when compared to the second body. Okay, after the start of A, the ratio of A1 is to A2 you are asked to find out. Anyhow, you are not aware of initial velocity, but it was given that it starts from rest. Even B also starts from rest. Okay, well, and the condition was given as 5th second. What was the condition given? 5th second. In the 5th second. So yes, nth formula. Okay, so anyhow, the only formula you need to use is Snth formula. Sn is equals to u plus a by 2 into 2n minus 1 is the only formula you will be using here. So two different conditions were given. For the first condition, how much distance it traveled? Unknown. Some Sn is equals to how much second? 5th second. Okay, so for 5th second, let me write it as some S5 equals to, initially it starts from rest, plus acceleration for the first body. Acceleration was given as a1 upon 2. How much time? 5th second. So n is taken as 5, 5 2 is 10. N is taken as how much children? 5 na? Okay, so 2 5 is 10, 10 minus 1 is 9. Hence the value of S5 is found to be 9 by 2A1. So this, keep it aside. Now again, for the second case. Second case, B also starts from rest only. But how far it travels? Only, though it travels equal distances in the 5th second, it travels 3 seconds lesser when compared to that. So for the second case, we have S3 only. Okay, if it happens to be 5, that should be 3 because it travels 2 seconds later. So S3 is equals to 0 plus its acceleration was given as a2 and time n was given as 3 now. So 3 2 6, 6 minus 1 is 5. So 5. Hence the value of S3 is given to be 5 by 2A2. This be equation 2. Children, but what is the given condition? As they travel equal distances in that particular second. Okay, this is these two distances are same. So what is the given condition? So the given condition is S5 is equals to S3. This implies 9 by 2 A1 is equals to 5 by 2 A2. This 2 and this 2 cancel. You are asked to find out A1 is to A2. A1 is to A2 means A1 by A2. Bring this A2 this side and take the 9 other side. So this implies A1 by A2 is equals to 5 by 9. A1 by A2 equals to 5 by 9. So A1 is to A2 is how much children? 5 is to 9. Here goes your answer. A1 is to A2 is 5 is to 9. Okay children. So distances in that particular second was given as equal. Okay, if travels for 5 seconds, it must travel only for 3 seconds. But that last second, 5th second, both are traveling the same distances. Next, the average velocity of a body moving with uniform acceleration traveling a distance of 3.06 meters in 0.34 meter per second. If the change in velocity of the body is 0.18 meter per second during this time, its uniform acceleration is. So, first of all, maybe the question is little confusing. Let us try to write the given data. So, average velocity of a moving body with uniform acceleration traveling a distance. So, what is initially given? Distance was given as distance was given as 3.06 meters The average velocity of a body of uniform acceleration traveling a distance of 3.6 meters is 0.34 meter per second. That means average velocity was given as how much? This is average velocity, not final velocity or initial. It is average velocity. Okay, u plus v by 2. This was given as 0.34 meter per second. Children, whenever average velocity is given, general formula you should use distance, speed equals to distance by time. Okay, that's it. Or velocity equals to displacement by time. Change in velocity of the body is again given as 0.18 during this time. Its uniform acceleration is. Because here it was given as average velocity, we have to use the formula average velocity equals to distance by time. So as distance is given and velocity is also given, from this you can find the value of t as s by v average. T is found to be s by v average. But you are asked to find not time, you are asked to find acceleration. In order to find acceleration, general formula for acceleration is nothing but change in velocity. The rate of change of velocity is defined as acceleration. Hence, change in velocity by time is nothing but your acceleration. So, change in velocity, how much is the change in velocity? If the change in velocity of the body is 0.18 meters per second, time you can find it out from here, substitute to get the value of that uniform acceleration. So let us try to find it out. First, find out the value of t. T is how much? S by v average. How much is s given? 3.06 by 0.34. Okay, just to remove this decimal, I multiply numerator with 100, denominator also with 100. 3.06 into 100 is 306. 0.34 into 100 is 34. So further simplification leads to, so 2 goes 17 times and 2 goes 153 times. 17 nines 153, 17 goes 9 times, hence the time is 9 seconds. How much time it took to travel? 9 seconds. So as the time is known, change in velocity was given. So you can find the acceleration as change in velocity upon time. What is change in velocity? 0.18. Time was just now calculated as 9. So this is nothing but 9, 0.1 goes 0 times and 9 2's 18. So its value is found to be 0.02 meter per second square. So here goes your answer. Okay, children? Well, moving to the next question. 15th question, a body travels for 15 seconds starting from rest. So initial velocity, how much they gave? 0. Starting from rest with constant acceleration. Of course, for the all the kinematic equations, okay, for all you need to take acceleration as constant acceleration, uniform acceleration. If it travels distances in the first 5 seconds, second 5 seconds, next 5 seconds respectively, the relation between S1, S2, S3. Yes, children, there is a slight correction in the numerical. First of all, let me correct it. Let me see. A body travels for 15 seconds starting from rest with constant acceleration. If it travels distances of how much? They need to introduce the distances, okay, because here it was given as S1, S2, S3. Small correction is the distances are S1, S2 and S3. So now read the question, children. A body travels for 15 seconds starting from rest with the constant acceleration. If it travels distances S1, S2 and S3 in the first 5 seconds, second 5 seconds and next 5 seconds respectively, the relation between here also, what is that? S1, S2 and S3 is. So you need to find the relation between S1, S2 and S3. So that small corrections are there. So anyhow, let us try to find it out. So children, for 15 seconds it travels. Okay, it covers S1 distance in 5 seconds, some S2 distance in another 5 seconds and some S3 distances in last 5 seconds. 5, total 15 seconds. Okay, but all the distances are not equal. Okay, it only travels with uniform acceleration. So first of all, in order to find out what is the formula for S1, children, this is nth case. 5 seconds, next 5 seconds, okay, like that you have asked. It's not nth, okay. So what is the formula, distance formula, children? S is equals to ut plus half at square. That's it. What is the formula? S is equals to ut plus half at square. Only formula you have to use is S equals to ut plus half at square. But it was given that the body travels for 15 seconds starting from rest. That means u is equals to 0. First case, only this particular distance if you consider, this is S1 is equals to ut. Distance is S1. This distance is S1. U initial velocity is 0. 0 into time plus half. Time, of course, it was given as how much this time given? 5 seconds plus half a t square. T square means 5 square. Isn't it? Hence the value of S1 is found. 0 into anything is 0. Half a t square. 5 square is 25. 25 by 2a. Case 1. How much is that? S1 was found to be 25 by 2a. Okay. Now to find out S2. Children, here the velocity was u is 0, but here velocity unknown. So earlier also you have solved this type of problem. If you are not aware of the velocity here, take the complete distance and take this initial velocity and the common acceleration here. So for the second case, you can't directly find the value of S2, but instead of S2, the whole you can find it out. The whole means it's not S2, its total is S1 plus S2. Case 2, find out S1 plus S2. Direct S2 you can't find. What is S1 plus S2, children? Again, for this total distance, initial velocity is taken as 0. So 0 into time. From here to here 5 and here to here 5. So total time was 10 seconds. So 0 into time plus half. Acceleration, same acceleration, uniform acceleration it will travel. Okay, constant acceleration. T square means 10 square. 10 into 10. 0 into anything is 0. Hence we found S1 plus S2 is found to be, this goes 5 times. 5 into 10 is 50. 50. Okay, so how much is that? 50, 50, 50. Don't cancel it. Better keep it here. Half into 10 into 10. Okay, 10 into 10 is how much? Okay, you can solve, but this is easier method. 10 into 10 is 100. Where is a? Half a t square. I forget to write a. Half a t square. 100 by 2a. S1 plus S2 is found to be 100 by 2a. Okay. Well, if S1 plus S2 is 100 by 2a, what is S2, children? S2 is nothing but 100 by 2a minus S1, isn't it? To find out S2, bring this S1 here. So minus S1. But what was S1? It is nothing but 25 by 2a. That's the reason why I kept 2 here instead of cancelling. So common denominator 2. So numerator is 100 minus 25. How much is that? 75. So S2 was found to be 75 by 2a. What is that? S2 was found to be how much, children? 75 by 2a. Now to find the case 3, to find out S3, again you have to find out. To find out S3, that you can't directly come from here to here. So again the total distance from here to here, let us find it out. What is the total distance? S1 plus S2 plus S3. What is the time? 5 plus 5 plus 5, that is 15. Okay. So based on that, let us solve. S1 plus S2 plus S3 is equals to 0 into 15 plus half a. T square means 15 into 15. That's it, children. So S1 plus S2 plus S3 was found to be 0 into anything is 0. 15 square is 225. Okay. So 225 by 2a. To find out S3, you have to bring S1 plus S2 the other side. But what is S1 plus S2, children? It is 100a by 2. So S3 can be written as 225 by 2a minus S1 plus S2. That means 100 by 2a. Children, LCM 2 is common. So 225 minus 100 is 125a by 2. So you found the value of S1 as 25 by 2a, S2 as 75 by 2a and S3 as 125 by 2a. So let us try to find out the relation between them. S1 is to S2 is to S3 is nothing but 25 by 2a is to 75 by 2a is to 125 by 2a. 2 gets cancelled. Hence the value of S1 is to S2 is to S3 is equals to 25 is to 75 is to 125. 25 goes 3 times, 1 is to 3 is to 5. Okay. Hence clearly if S1 is 1, S2 will be 3 and S3 will be 5. Okay. Reverse pattern. If S1 is 1 and S2 is 3, then S2 and relation between this is 1. S1 is 3 times of S1 is 3 times of S2 is S1, or S1 equals to S2 is equals to 1 by 3rd of S1. Okay, children. No place is there, so don't get confused here. S1 is to S2 is to S3 was found to be 1 is to 3 is to 5. Okay, 3 parts and 5 parts. If you come to the reverse way, S2 is equals to 1/3 of S1 and S3 is equals to 1/5 of S1, because it is not 1 is to 3 is to 5 is not given. S1 is equals to 1 by 3 S2. Yeah, here S1 is equals to 1 by 3 S2 and S2 is S3 for S3 it is 1/5. So check it out, children. We got it as 1 is to 3 is to 5. Reciprocal means just take the LCM and bring it here. Then you can also go with this. I can explain it. For your simplicity, let me explain. Only using these two. S1 is to S2 is given as 1 is to 3. This implies S1 by S2 is equals to 1 by 3. Hence, bring this S2 or the other side, then S1 will become how much? S2 by 3 or 1 by 3 S2. Got it, children? So S1 is equals to 1 by 3 S2. I hope it is clear now. Similarly, if you go with S1 is to S3, S1 is to S3 is given as 1 is to 5. Only these two I am comparing now. Okay, earlier I compared these two, now 1 and 3. What is S1 is to S3? 1 by 5 or S1 by S3 is equals to 1 by 5. So S1 can also be written as S3 if you bring it here, 1 by 5 of S3. S1 is equals to 1 by 3 of S2. S1 is equals to 1 by 5 of S3. Now it's clear, children. So lack of space I tried, but okay. So moving next to the next question, that is 16th question. If a body having initial velocity 0, how much is that? Initial velocity is given as 0. Moving with uniform acceleration. The distance traveled by it in 5th second will be simple. Basic question it was asked you. Just take the formula, nth formula. Fifth second means nth formula. What is nth formula? U plus a by 2 into 2n minus 1. That's it. So which travel? Fifth second. Fifth second means n is taken as 5. Initially velocity was given as 0 plus uniform acceleration. How much? Value is given means acceleration they should give. Let us take the acceleration, assume the acceleration. Correction children. Take the acceleration as 8 meter per second square. Okay. To get these options, one of these options you should take acceleration as 8 meter per second square. Okay. Just correct it. So acceleration now let us take it as 8 meter per second square upon 2 into 2. N is 5 minus 1. So S5 is equals to 8 by 2 is 4 into 5 2 is 10, 10 minus 1 is 9. So in fifth second the distance traveled will be 9 4s 36 meters. How much is that children? 36 meters. So here goes your answer. Okay. Now the last question. A body starts from rest. Of course, initial velocity is 0. What is the ratio of the distance traveled by the body during the fourth and third second? Again the same formula. So you have to use the formula nth formula. Nth formula is u plus a by 2 into 2n minus 1. Two different conditions they were asking you. First one, fourth second. So S4 equals to velocity rest. Starts from rest 0 plus acceleration a by 2. N was given as 4. So 2 into 4 minus 1. So S4 is equals to 4 2s 8. 8 minus 1 is 7. So 7a by 2. Case 1. And what is the case 3? 2? S3. S3 means S3 is equals to initial velocity again 0 plus a by 2. 2 times of that is n is taken as 3 minus 1 or S3 is equals to a by 2 into 3 2 6 minus 1 is 5 5a by 2. So what you are asked to find out? Ratio of the distance travelled by the body during the S4th to S5th. You are asked to find out ratio of these two distances. S4 is to S3. S4 was 7a by 2. S3 was 5a by 2. A cancel, 2 cancel. Answer is 7 by 5. So here goes your answer. So with this we have completed the exercise. So let us meet you in the next class. So thank you for your attention and prepare well. Thank you.